In the following tutorial, we will explore the save variable function, which is used to store data in a structured format. This function helps us save settings or variables persistently, ensuring they remain available even after restarting the script. The save variable function takes two parameters. Mixed variable is the data we want to save. It can be a table, a number, a string, or any Lua-supported data type. And string file name is the name of the file where the data will be stored. Typically, we use a configuration file to save settings. In our script, we use save variable to store the user's settings inside a configuration file. This allows us to maintain custom values such as speed hacks, aim assist, and damage multipliers. For example, when the user selects exit from the menu, the script saves all the current settings. This ensures that the next time we run the script, the settings are loaded correctly. The script first defines on and off as toggle states for different settings. Next, it creates config file, which generates a file name by appending .cfg to the script's file path. This file stores the settings. Then, the script attempts to load the configuration file using load file. If the file exists, settings is assigned to the function returned by load file. The script then calls the settings function, executing it, and assigns the result back to settings. This step retrieves and stores the saved settings. The script checks and adjusts the settings. For speed hack, it sets the value to on if it was previously saved as on, otherwise, it sets it to off. For aim assist, it does the same. If it was saved as on, it stays on, otherwise, it switches to off. For damage multiplier, it tries to convert the saved value to a number. If the value is not valid, it defaults to 1. This ensures all settings are correctly initialized. If the configuration file does not exist or there are no saved settings, the script creates a default settings table. This table sets speed hack to off, aim assist to off, and damage multiplier to 1. These default values ensure the script starts with a valid set of settings even if no saved data is found. The setSpeedHack function takes one parameter, state. If the state is on, it sets the game's speed to 3.0 and shows an alert saying speed hack enabled. If the state is anything else, in this case, off, it sets the speed back to 1.0 and shows an alert saying speed hack disabled. This function controls the game's speed based on the state passed to it. The setAimAssist function takes one parameter, state. If the state is on, it will execute your code to enable aim assist and show an alert saying aim assist enabled. If the state is anything else, in this case, off, it will execute your code to disable aim assist and show an alert saying aim assist disabled. This function controls the aim assist based on the state passed to it. The setDamageMultiplier function takes one parameter, multiplier. First, it checks if the multiplier is less than 1. If it is, it sets it to 1. Next, it checks if the multiplier is greater than 5. If it is, it sets it to 5. Then, it updates settings damage multiplier with the adjusted multiplier value. Finally, it shows an alert, followed by the new multiplier value. This ensures the multiplier stays within a safe range, preventing issues and maintaining balance. The UI function displays a menu with several options using the choice function. It creates a list of choices for the user. Speed hack with the current speed hack setting. Aim assist with the current aim assist setting. Damage multiplier showing the current multiplier value. Exit to close the menu. The choice function displays these options and waits for the user to select one. If the user does not select an option, the function simply returns and does nothing further. If the user selects the first option from the menu, which corresponds to Speed Hack, the script checks the current state of setting Speed Hack. If setting Speed Hack is already set to on, it switches it to off, and if it is off, it switches it to on. Then, it calls the Set Speed Hack function with the new state, either enabling or disabling the speed hack accordingly. If the user selects the second option from the menu, which corresponds to Aim Assist, the script checks the current state of settings Aim Assist. If settings Aim Assist is set to on, it switches it to off, and if it is off, it switches it to on. Then, it calls the Set Aim Assist function with the new state, either enabling or disabling the Aim Assist accordingly. If the user selects the third option from the menu, which corresponds to Damage Multiplier, the script prompts the user to enter a new value for the damage multiplier, within the range of 1 to 5. The prompt function asks for input, using the current settings damage multiplier as the default value. It expects the user to enter a number. If the user provides a valid number, it is converted to a number using toNumber function. The script then calls the Set Damage Multiplier function with the new value, updating the damage multiplier accordingly. Note that the values used for the damage multiplier are placeholders. To make the script functional, you will need to adjust the code and replace these placeholder values with actual values specific to a game. This ensures the multiplier is correctly applied within the game. If the user selects the fourth option from the menu, which corresponds to Exit, the script executes the following. The save variable function is called with the settings table and the config file as arguments. This saves the current settings into a configuration file. This ensures that these settings persist and will be available the next time the script is run. After saving the settings, a confirmation message is shown using an alert. This lets the user know that their preferences have been successfully saved. The script then calls the OS exit function, which stops the execution of the script and exits the program. The final block of code starts a while true loop, keeping the script running indefinitely. It checks if the GameGuardian interface is visible. If it is, it hides the interface and calls the UI function to display the menu. If the interface is not visible, it sleeps for 100 milliseconds using the sleep function to reduce CPU usage. This loop ensures the script runs continuously and the menu remains functional until the user exits. The goal of this tutorial series is to provide practical examples, encouraging you to type the code yourself. This hands-on approach helps you learn more naturally and effectively. Making mistakes is a key part of the learning process. By working through issues, you get a deeper understanding of how the code works and how to troubleshoot it. That is why I do not simply provide scripts to be copied and pasted. It is about building your coding skills through practice and problem solving. The save variable function is a powerful tool for storing data persistently, such as saving user settings, preferences, or even temporary authentication tokens. It can be used in various situations where you need to store data between script runs, like saving passwords or other sensitive information securely, although always keep in mind to protect such data properly.